Leetcode question 118 Pascal's triangle. Given the number of rows, return Pascal's triangle for that many rows. And as you can see from the animation, all the boundary values of each row in Pascal's triangle are 1, and the internal values follow this rule that each number is the sum of two numbers directly above it. Now if you remember, this looks exactly like one of those pattern questions we all used to do in school, college when we first started learning computer programming. And in fact, it is actually the same. But if it is that basic, why is it still being asked in the interviews by the big companies like Amazon, Apple, Microsoft, Goldman Sachs, etc.? Let's find the answer to this question in this video ahead. Hello there, this is Shubha, and my goal is to make you fall in love with data structures and algorithms so that you can crack your next big tech interview. I also talk about JavaScript and front-end development on this channel because that's what I do while working as a software developer at Microsoft. But irrespective of whether you aspire to be a front-end, back-end or a full-stack developer, you need to master the problem-solving skills to get a good job. So without wasting more time, let's get back to our Leetcode problem. We have already seen the overall logic to form Pascal's triangle. Boundary values are always 1 and each internal number is the sum of two numbers above it. But now let's try to analyze few more things which will help us get near to the solution of this problem. First, what would be our answer format? Array of arrays? Yeah. It won't be a 2D matrix, but instead size of each row would increase by 1 as we go down. And not only this, the length or size of each row would be exactly equal to the number of row. That is, first row will contain 1 element, second will contain 2, third row will contain 3, and so on. So let's write the code based on the above analysis. So at first we initialize our result variable with an empty array with the size of num rows, as we know that our result is going to contain num rows number of rows. Now since we have to have multiple rows and columns, we would always need two for loops. The first loop will be responsible for each row, while the nested for loop will be responsible for the columns or the actual values for each of the row. Now before jumping on to the second for loop, you know that each row will contain an array of numbers and each row will have exact same numbers of values as the row number. So let's initialize each row with an array of size I plus 1 because we are at I plus 1th row for every I. That is, for I equals to 0, we are at first row. For I equals to 1, we are at second row, and so on. And we also know that first and last element of every row is going to be 1. So we initialize row of 0 and row of I to be 1. Now, for filling the rest of the values of each row, let's write our second for loop. This will start from index 1 and go till index I minus 1 because we have already filled 0th and ith position. Now each value of the row of j, must be equal to the sum of its above two numbers, that is result of I minus 1 j minus 1 plus result of I minus 1 j, where result of I minus 1 signifies the previous row. And once this loops end, that is j reaches I minus 1, all the values of this row would be assigned. So after that, let's add this row to the result array and iterate till num rows to fill all the rows in similar fashion. And finally, return the result. That's it. Let's try to run it to check if our code is correct or not. Looks like it passed both the test cases, so let's try to submit it. Our code got submitted successfully without failure in any test cases. That's great. But this looked pretty straightforward, and you must still be thinking, why would the big tech giants ask these questions in their interviews? Let's get to that, but first let's discuss the time and space complexity of this, which is fairly simple to calculate in this case. Since there are two for loops, each going to almost n every time, the time complexity would be big O of n square, where n is the given number of rows. And since we are storing the result in array of arrays, the space complexity is also going to be big O of n square. Now let's find out the answer we are waiting for since the beginning. Why big companies ask this in their interviews? The answer is they almost always ask you follow-up questions if they ask this question. But you still need to solve this first, so the solution which we just discussed was very important. So the follow-up questions might be, they don't want the entire Pascal's triangle now. They just need rth row, or they just need the number at rth row and cth column. So for rth row and cth column, the trick here is actually either you must identify the pattern or know this concept beforehand that every number in the Pascal's triangle is r minus 1, c minus 1. Where r is the row and c is the column. So for third row and second column, the formula would be 3 minus 1 C2 minus 1. For fifth row, third column, the formula would be 4C2. And we all know the formula of combination of NCR is n factorial divided by r factorial into n minus r factorial. And factorial calculation is a big O of n complexity operation because you have to multiply each number from n to 1. So for rth row and cth column, the time complexity would be big O of r because r will always be greater than or equal to c, as this is Pascal's triangle. Now let's talk about the second variation, which is printing out the entire row. If you say, Shubha, you just now calculated the value of rth row and cth column, using the same formula, just calculate each value in the rth row. And yes, while that is correct, it is not a very good solution. If you remember, in Pascal's triangle, the number of values in a row is same as that row number. So if you calculate using the same formula, the time complexity would go to big O of r square, because one value calculation takes big O of r and we are calculating r numbers in the rth row. So it becomes r into r, which is r square. So here's the catch. Now we would need to optimize this to find the whole row in big O of r. Okay, let's try. We know the first value is always 1. Next value is r minus 1, which is nothing but r minus 1 c1, which when expanded will look like r minus 1 factorial divided by 1 factorial into r minus 1 minus 1 factorial, which can be further written as r minus 1 into r minus 2 factorial by 1 into r minus 2 factorial, which can be written as r minus 1 by 1. You'll understand in a minute why I am writing it in this form. Now let's try to analyze the next value as well. This value will be r minus 1 c2, which when expanded will look like r minus 2 factorial divided by 2 factorial into r minus 2 minus 1 factorial, which can be further written as r minus 1 into r minus 2 into r minus 3 factorial by 2 into 1 into r minus 3 factorial, which can be written as r minus 1 into r minus 2 by 2 into 1. So if you observe this carefully, you'll find a pattern in these terms. Every time we move to a next column, we multiply by r minus that column number and then divide by that column number. So for column 1, 0th column value is multiplied by r minus 1 and divided by 1 because column value is 1 here. For column 2, first column value is multiplied by r minus 2 and divided by 2. And similarly for column 3, second column value is multiplied by r minus 3 and divided by 3. So that's how we can do it in big O of n, because for every next calculation we are multiplying by r minus that column number and divided by that column number. So we can do it in big O of n. This can be done in just 3 to 4 lines of code, but I'm not writing it for you. I'm leaving this as a challenge for you. Let me know if you are able to write the code for this in the comment section. So that's it guys, we have completed yet another Leetcode question and also covered its different variations which can be asked in an interview. Let me know if this was helpful for you in the comment section, and also please like, share and subscribe. That keeps me motivated to bring new Leetcode solutions to you. Thank you. Bye bye.